Well, this is John Black, super chemist. Gonna make some chromium hydroxide. I actually was making a whole mole of it, and I lost the footage. So I did take out 5% of that mole that I was gonna make, so I could show you how to crystallize the chromium chloride. So here it is. I'm gonna start with it. Putting it in this water. That's why it was green. Throw some water in there, make sure that I get it all out. Alright, so I got some sodium hydroxide here already put in the water. The ratio is supposed to be 1 to 3. So, there we go. See how there's a precip. Oh, you probably can't tell on tape, but I think it needs more. Usually I add another mole in there, or another mole equivalent. So wait out some more, another mole equivalent. Alright, this was 5% of a mole. So 5% of a mole of this is 2 grams. So far, and I needed 3 to be stoichiometry correct. So that'd be 3 times 2 is 6. So I did put 6 in, and now I'm getting ready to put in another 2 grams, which would be like putting 4 equivalents in instead of 3. This is after about a half hour, so you can see it's starting to form a top layer there. The precip is starting to move down. Now, if I seen any green in there, I would add some more sodium hydroxide. There's some color in there. You know, it turned from green to blue. Well, this is after about a half a day. You can see it's kind of clear. I mean, it's not green, it's blue now, so it's just the particles floating around in there. It won't settle. That's one of the problems you have with this that's different than other hydroxides you can make. It does not want to settle to the bottom. So I'm going to put it in a bigger container. This time it won't settle much, but it should settle down to here. We'll see. Now this is just after 20, 30 minutes or something like that. The water's still murky, but you can see 99% of the crap dropped to the bottom. And if I let that sit for a day, this will be clear as water. I mean, it's clear as water almost right now, but it is a little murky. All right, so it's been a couple hours. It hasn't been a full day, but it's pretty clear. So basically what I'm going to do is I'm going to pipette this stuff out without making the stuff on the bottom jump all up in that. You know what I mean? Don't agitate it. And after I get this empty all the way down to the bottom almost, I'll basically fill back up 5 and repeat this process 5, 6, 7 more times. When you get down to the bottom, don't be careful not to suck any of that stuff up on it with your water. You know what I mean? You want it to be nice and clear. Want to add more water, like I said. would stir it up, but it's such a small container, the act of pouring the water in stirs it up by itself. Again, I'm just going to let that sit, and when it settles down, I will take that out. Now, if I do that 6 or 7 times, you figure I'm taking out at least 75% of the soluble stuff each time. So you can see it's already starting to settle there. See, now, this is just 20 minutes later, and it's already cleared up, so I'm going to do it. I could wait a little bit, let this settle down more, but just so I get a big bulk, I want to at least get 75% of the water out, because that's a big bulk of the ions that I'm getting out too. So anyways, I did a whole mole. Like I said, I lost the footage, but when you're doing a whole mole, you're not going to be able to use this little pitcher here. You're going to have to use this. It's just a basic kitchen garbage can, standard size. And then this right here. That's basically just a siphon that you buy if you have a fish tank and you want to siphon the water out to clean it or whatever. And I let the garbage can, let the stuff settle down to here. And then I would drain it out and basically do the same thing I'm doing with the pitcher. It's just a bigger size. So that's the new, that's the bigger one. After it got into the garbage can, I took it down to that. And basically each day I'll pip that a little bit out. What I did was I spilled out all the stuff that was liquid, too liquidy. And this was actually liquidy too, but not enough to separate any of the water, pour it out or whatever. So I put it on my radiator so it would heat up. As you can see, it's drying up if you look. But it's still like pudding. See how it's like pudding. So there's the bottle I poured most of the liquid off into. As you can see, there's a water layer. I will pour that water layer out and keep trying to do that each day until I can get it down to less liquid. As you can see, the water's still pretty clear there. Once I get that down, a little bit more water out of here, what I'm going to do is I'll pour it back into that big box up there, and I'll put that on a radiator, just let it evaporate the water off. We're going to have some contamination. You figure we washed most of the salt out that was ionic, ions. But there is a trace amount in there. But I figure when I crystallize and recrystallize the potassium dichromate I want to make, it'll purify it then. And also, I'm going to add that 5% of a mole, because this stuff over here is the big stuff is 95% of a mole. This is the 5% of mole I took out so I can recrystallize the chromium chloride I made. But I want to put them together. Now, what I did was that big container, I got the spatula, and I scraped all the crap out of it. As you can see, it's right here. Right there in that dish. It looks like a pile of crap, a wet dump someone took on here that's blue. And there's the big container. It's all empty. I left some in there because I still have some in that 1 gallon bucket. And as I get more water out of there, I will pour it into here, let it dry out a little bit, and then put it onto the pie dish like that. Now I have a tip. This is a great tip for a home chemist. Uh, if you have natural gas, if you have natural gas, that means your oven has a pilot light on it. So that means that your oven is actually at like 100, 110 degrees or something inside there, or whatever the temperature is. It definitely is not room temperature. Because I put these pie plates, I'm going to put them right into the oven. I'm not going to turn the oven on. I'm just going to let it sit in there. After a week or two, it'll dry up, and as it dries up, I will each day I'll go in there and I'll cut it up into smaller pieces and pulverize it, and then it will be, it'll be nice powder. Well, I didn't give a yield, but like I said, this kind of thing, it's usually quantitative or whatever, where you're gonna get a very high yield. Here's some from some I made last year. You can see it's blue. Basically, what we're doing here, it's a lot of transition metal hydroxides they're not soluble in water. So that's a good thing in a way, because sodium hydroxide, and you can do this with potassium hydroxide also, but it's a lot easier for me to get sodium hydroxide because you can buy it pure, which I showed you in another video how to buy it pure. So basically, you're just going to get sodium hydroxide, mix it up with a transition metal. Since the transition metal hydroxide is not soluble, it will come out of solution, and then you'll be left with this salt, see. This was our stoichiometry. We used 3 moles of sodium hydroxide, 1 mole of chromium chloride was our salt, and we ended up with 3 moles of sodium chloride and 1 mole of chromium hydroxide. Now I want you to look at this next thing. Now if you see here, we ended up with 1 mole of sodium hydroxide, because remember we put an extra mole in. Now, that's up to you. I mean, I'm impatient. Maybe you don't need that extra mole and the stuff will separate without it. Maybe it just takes a little longer. I'm kind of impatient though, so I did add an extra mole of that, and helped it to separate, I believe, more. I mean, but like I said, I'm impatient. Maybe give it a try without that, without putting the extra sodium hydroxide in, then you won't have that extra contamination. But anyways, I did, and plus I made 3 moles of sodium chloride, right? Because I mixed my 5% and my 95% together. But anyways, if you figure out, you want to do at least a 75% wash. Now that means that 75% of the volume of the water, say in the garbage can, that you're going to dump out after it separates, after the precip goes to the bottom, you're going to want to dump all that clear water out. Well, you want that to be at least 75% of the garbage can, and that way 75% of the ions will be taken out. I want you to look at the math here. You start out with a mole, but when you wash 75% away, you multiply by 25%, right? 0.25, and you get a quarter mole. Sodium chloride, you'd have 2 1/4 moles after you were done with 1 wash. Now look on how it goes exponentially higher. You get down to the bottom here, you're up to 262,144ths, or 262 144 of a mole. So that's like nothing. I figured out the grams of it for sodium hydroxide. This is after 9 washes. You would have 32,766 of a gram. Sodium chloride, and that's the one where you got a lot. You got 3 moles of that. You're only getting 2,000ths of a gram, and that's in the whole. That's contaminating the whole thing. You know what I mean? I have a mole, so out of the mole of the stuff, I'm going to have this much contamination on it. I think I can live with that or get rid of it with recrystallization later on. Always remember, science is great.